Here we are on page 17. First, we're going to do these two problems here, which are graphing problems. For the following functions f, find the equation of the inverse function, sketch the graphs of the function and the inverse function on the same set of axes, and state the domain and range of the function and its inverse. Find any asymptotes and intercepts of the function and its inverse. Okay, so we're going to do first this function y equals e to the x plus 5. So to find the inverse function of this, we're going to use variable interchange. So instead of y equals e to the x plus 5, what we're going to do is we're going to exchange y for x and x for y, and then we get this. And then we try to solve for y. And so the way we solve for y, first we're going to subtract 5 from both sides. We'll get x minus 5 equals e to the y. And then to get y as a regular number, we're going to have to take the log of both sides. And what kind of log we're going to use? Well, since it's an exponent to the e, the easiest thing to use would be the natural log. Natural log of e to the y. Natural log of e to the y is just y. And then we have natural log of x minus 5. Okay, so this is the inverse function. Okay, and then it says to sketch the graphs on the same axes. So the e to the x function, let's see, if we put the x and y axes here, then if we made a little chart to graph the x's and y's for e to the x plus 5, e to the negative 1 would be would give us, let's see, if we're using the calculator on this, we would just say, okay, the function, and we'll put e to the x, e to the x, which is second natural log, and we'll put x, and then we'll add 5. So let's graph that. Okay, and then we'll look at the table. So negative 1 will give us 5.36. 5.36. And then, well, actually 5.37. And then 0 would give us 6. And then 1 would give us 7.72. Okay? So if we were going to graph those, we would graph them here as negative 1. Negative 1 would give us about positive 5. 0 would give us 6. And then 1 would give us 7.72. 7.72, something like that. Okay? Alright. And then the domain and range of f would be, well, the domain is going to be all the real numbers, and the range is going to be, there's going to be an asymptote here somewhere. So like, let's see on the calculator where the asymptote is. Looks like it's 5, right? Does that make sense? Because like e to the x, the smallest it's going to be is very close to 0. So the range is going to be that 0 plus 5. So that makes sense, right? So y is actually going to be any number greater than 5. Okay, so actually the asymptote is at 1, 2, 3, 4, 5. It's going to be right there. Okay, and then if we were going to draw the inverse function, which is log of x minus 5 equals y, the easiest thing to do would be to just say, okay, I'm going to draw the reflection line here, And then I'm going to reflect this graph about the reflection line. So I would put, instead of -1, 5.37, I would put 5.37, -1. Instead of 0, 6, I would put 6, 0. Instead of 1, 7.72, I would put 7.72, 1. Okay, so that would be the reflection there. So that, and then find any asymptotes and intercepts. Well, the asymptote, remember, of the exponential function is y equals 5. For the inverse function, the domain would be x is greater than 5, right? Because this would just be a reflection 1, 2, 3, 4, 5. And then the range of the inverse function would just be like all real numbers. Okay, so like, do you see how this is the opposite of this, and this is the opposite of that? Okay, they're like correspond to each other. Okay, all right. Now let's do the function log of x minus 4. So log of x minus 4. Log of x minus 4. I'll do second table. Okay, and you see, like, up until x equals 5, there are no legal values for it. So let's see. So that means from 0 to about 4, well, actually, let's put the axes here. Okay, so 0 to 4, nothing happens. Then at 5, 0, there's a point. 1, 2, 3, 4, 5, 0. And then 6 would be a little bit bigger than that. And then 7 would be a little bit bigger than 1. Okay? So that's what our function looks like. The asymptote is going to be, you can see that, like, the value that makes the log negative would be anything smaller than 4. So the asymptote would be at 4. Okay, and so if we wanted to reflect that, it would be we would reflect it across that line, and that would give us, let's see, instead of 5, 0, we'd have 0, 5. Instead of 7, 1.09, we'd have 1.09, 7. All the points would be the opposite, and then we would just have something where it's like flipped 45 degrees. Okay, and then so the rest of it kind of is the same as the first one, because we just sketched the graph. Then we're going to look at the domain and the range. Well, the domain of this one is x is greater than 4. The range is any real numbers. Now for this one, it's the opposite. The domain is going to be any real numbers, and the range is going to be y is greater than 4. And then asymptotes and intercepts. Well, one of the asymptote for the log function is at x equals 4, and the asymptote for the exponential function here is going to be y equals 4. Okay, and intercepts, we found that here, right? Well, if we go back and we find the intercepts for this one, we could use the trace function. So I'm just going to find the intercept for the a. I'm going to put e to the x, just show you how to do that. Second, e to the x plus 5. So we're going to graph it. Okay, and then we want to see where that intersects the y-axis, because it's never going to intercept the x-axis. And the way we figure out where it's going to intercept the y-axis, we just type trace and then we hit 0, and it'll tell us that the y value is 6 there. Okay, for e to the x plus 5. 1, 2, 3, 4, 5, 6. Yeah, it was there. Okay, so that is the intercept here would be 0, 6, and the intercept here would be 6, 0. Okay, next one. Given the function e to the 2x and g 2x minus 1, find, okay, inverse f of x, composite function with g. So inverse of f follows g. So the inverse of e to the 2x, let's try to find that. So it would be y equals e to the 2x. Then we would use variable interchange. So we get x equals e to the 2y, and then we're going to solve both sides, or we're going to put y on the left side by itself. So we take the natural log of both sides. Natural log of e to the 2y is the same thing as 2y. And then we'll have y equals natural log of x divided by 2. Okay, so this will be f of negative 1. And then g is just 2x minus 1. So first we'll do 2x minus 1, and then that will be followed by natural log of that divided by 2. So that's what that would equal to. Okay. Now what about g follows f and then the inverse function of that? So first we're going to do f, which is e to the 2x, and then we're going to put that inside g, which would be 2x minus 1. And then we're going to take the inverse function of that. So what does the inverse function of that look like? Well, we're going to replace y with x and x with y. And then we're going to solve for y. So we add 1 to both sides. We get x plus 1 equals 2e to the 2y. Divide both sides by 2. Now we have e to the 2y. With that, we'd have to take the natural log of both sides. X plus 1 divided by 2 equals, the natural log of e to the 2y would just be 2y. And then we divide both sides by 2, and we get y equals natural log of x plus 1 divided by 2, all divided by 2. Okay, so that would be the inverse, that would be this. The inverse of g follows f. Okay. Consider the graphs a and b. One of them is the graph of log x, and the natural log x, and the other is the graph of y equals natural log of x minus 2. Identify which is which, give evidence for your answer. Well, let's try to find just some points. So like for example, we see that there's a point here with x equals 1. Let's try to find out what these are when x equals 1. Well, natural log of x, the natural log of 1 is going to be 0. So the point on this one is going to be 1, 0. Okay, so we already know that this one here, this blue one here, this one is y equals natural log of x, and we know that because if you put x equals 1 in the natural log of x, it gives you 0. What happens if you put x equals 1 into the other one? You had 1 minus 2. You'd have y equals natural log of 1 minus 2, which is illegal. Natural log of a negative number is nothing. And you can see that, like, you can see there's an asymptote here. And so, yeah, 1 is not even in the domain of this other one. Okay? So those are two pieces of evidence you can use. Copy the graphs onto a new set of axes, add to them the graph of y equals natural log of x plus 2. Where would that be? Well, you can see that doing x minus 2 shifted the blue graph to the red one. So it shifted to the right. So when you did x minus 2, it shifted to the right. So what do you think is going to happen if you shift, or if you do plus 2? It's probably going to shift in the opposite direction. But the way you could test that is you could just like make a table for this one here. And so like for example, if you put 0 into this, you would get natural log of 2. And if you put negative 2 in there, you would get log of 0, which is negative infinity. And if you put negative 1 in there, it would give you natural log of 1, which we know is 0. So now we can see that, the x-intersect point is going to be negative 1 comma 0. So if we wanted to graph that, we would put that right there, right? Negative 1 comma 0. And then the rest would just be the same graph shifted. So the asymptote for this one is going to be at negative 2, we can see. And then the x-intercept is going to be at negative 1. Find the equation of the vertical asymptote for each graph. Okay, so for the red graph, the vertical asymptote is at x equals 2. And for the blue graph, the asymptote is at x equals 0. And for the purple graph, the asymptote is at x equals negative 2. Okay. 5. Kelly said that in order to graph y equals natural log of x squared, you could first graph y equals log x and then double the distance of each point on the graph from the x-axis. Is Kelly correct? Explain your answer. So basically what Kelly is saying is that you could, instead of graphing the squared value, what you do is you just say, instead of graphing y equals natural log of x, I'm going to graph y equals 2 times the natural log of x. I'm just going to double the points. So like, if this is 1, this will be 2. If this is 2.5, this will be 5, for example, right? So it's just going to double all the distances from the x-axis. So is it y equals 2 to the natural log of x? Are these two equal? Now remember, there's a rule of logs that if you have the natural log of a to the x, that is equal to x times the natural log of a. So if you use that law, on this right side, you would say 2 natural log of x is equal to 2 natural log of x. Hey, that worked out. Yeah, so that makes sense. Here we're going to try to figure out the inverse function of e to the x plus 3 plus 2. The way we're going to do that, of course, is variable interchange. So we will substitute x's in for y's and y's in for x's, and we get this. And then we're just going to do algebra to isolate y on the left side. So first we're going to subtract 2 from both sides. We'll get x minus 2. These will cancel out. E to the y plus 3. Then we're going to take the natural log of both sides. Natural log of x minus 2 is equal to y plus 3, because natural log of e to the something is just something. Subtract 3 from both sides, and we get natural log of x minus 2 minus 3 is equal to y. And then we just write y on this side. And this is our inverse function already. Okay? Now we go to the next part. It says, find the values of x for which f of x is less than 2.1. So anything where you're actually finding the logs of a certain number that's not a power of that number, you're going to have to use the calculator anyway. So we're going to enter this function in the calculator. That would be e to the x blue natural log, okay? And then we're going to put x plus 3, x plus 3, and then we're going to do minus plus 2. And then we're going to see that in a table. And then if we look at the values, we're going to see that to get below 2.1, we go to, there we go. So like anything less than -5. So we'll say like for this one it would be x is somewhere less than -5. And then 2, they're asking when would f of x be less than 2.01? That would be anything less than -7. So it would be like x is less than -7. What about less than 2.001? That would be anything less than x is less than, something like x is less than -9. What about 2.0001? So that would be like x is less than -12. Hence conjecture the horizontal asymptote for the graph of f. Well, it looks like the horizontal asymptote is at y equals 2, right? Determine the equation of the horizontal asymptote by discussing the behavior of f of x as x approaches positive or negative infinity. Well, let's see. If you put a really big number in for x, what you end up with is e to the negative of a really big number plus 2. Well, e to the negative big number is the same as 1 over e to a big number, positive big number, plus 2. And e to the big number is just a big number, so that's basically just saying 0 plus 2, which is 2. So when you put a negative big number in for x, then yes, you get an asymptote of 2. If you put a positive big number in, then you just end up with a really big number. So there is a horizontal asymptote when x goes to negative infinity, but not when x goes to positive infinity. D. Determine the vertical asymptote in the domain of f of -1. Well, if there's a horizontal asymptote of f of x, and it's at y equals 2, then the vertical asymptote of f of -1, or the inverse of f, is going to be at x equals 2, because it's the opposite. What's the domain of f inverse? Well, if the range of f is something, and we're going to say that the range of f is going to be y is greater than 2, because it can't be 2 because that's the asymptote. Anything below that, it's also not going to be. So the range of f is going to be y is greater than 2. So the domain of the inverse function is going to be the same thing. It's going to be x is greater than 2. Okay? So that's all it was asking.